2.3, number 93. All right. It says, use direct substitution to show that each limit leads to the indeterminate form. Indeterminate form 0 over 0. And then evaluate the limit. What is this indeterminate form? So let's look at this problem here. It says limit as x approaches 4 of x squared minus 16 over x minus 4. All right, we said a moment ago that with the quotient law for limits, that the limit of a quotient of two functions, like here, as x approaches a, is equal to the quotient of the limits leaving off the x approaching a for one moment, as long as the limit of g, the denominator function, as x approaches a, is not 0. That would have to be guaranteed. Then this would hold. Right? A. All right. But here this is not the case. All right. The bottom is 0 as x approaches 4. Certainly the denominator is approaching 0 as x gets closer to 4. The overall denominator gets closer to 0. Right? So to the numerator, actually, as x goes towards 4, x squared, of course, goes towards 16. Therefore, the overall numerator goes towards 0. So this is what you call a 0-0 case in indeterminate form. It's indeterminate because I don't know what's happening. It's undetermined. As the top goes to 0, the fraction gets smaller. As the bottom goes to 0, the fraction gets larger. How these interact, I don't know. Right? It could come out to be infinite, could come out to be 0, could come out to be something in between, some finite value between them. But it turns out that since x will never be 4, because we never concern ourselves with what's actually happening at x equals 4 itself. So whenever we're talking about a limit as x goes to 4, x goes to a, whatever it is, we're never concerned with what's happening at a. It doesn't matter. So at 4, I don't care what's happening. So the limit of x squared minus 16 over x minus 4 is, of course, if I factor it, the same as the limit of x minus 4x plus 4, classic difference of squares, over x minus 4 as x approaches 4. There's no doubt that is true. All I did was rewrite how the numerator looks, but there's something more going on. As long as x is not equal to 4, which it will not be in this consideration, because x is only getting arbitrarily close to 4, it is not actually going to become 4, so therefore it's not going to be 4. And that means that since x will not be 4, these cancel, and the original function, x squared minus 16 and x minus 4, will always be exactly the same as x plus 4, as long as x is not 4, which again, it will not be. We're only approaching 4. So therefore, this function here and this function here are equal for all values except for this one. And therefore, we can replace x squared minus 16 and x minus 4 with a simpler expression, a polynomial expression, x plus 4. X approaches 4. So now the whole problem with the bottom going to 0 is eliminated. And we can now use direct substitution because this expression is a polynomial and therefore it's continuous everywhere. So direct substitution leads to plugging 4 in, and we will get that the limit is, of course, 4 plus 4, which is 8.